Hi everyone, welcome back to this channel. This is part 2, an updated version of my chess move generator comparison. I want to make an update just to add more languages, also some of the algorithms. Sometimes I use different kind of strategies in different languages, like sometimes I would use a board struct and copy it each time, or others would use global variables. So I wanted to make it more consistent and make sure the performance is as good as possible in most languages. So of course I can't try every language. And there are some people recommended using Carbon. Obviously, that's the problem with Carbon is it says on the actual GitHub, don't use it, it's not ready. So I'm probably not going to use it when it's not ready yet. Other things like functional languages would be extremely hard for me to do because I have no knowledge in that. You can't just copy and paste, fix the errors. It would take me days, honestly, to do a functional language because I have almost no expertise in functional languages at all. Of course, this won't give you the definite say, oh, this language is definitely faster than this language. This is a very specific example, which mostly covers recursion and stack variables. It doesn't allocate much on the heap. It doesn't deal with strings. It doesn't deal with input. It doesn't really deal with many things. It's a very specific example, and it depends on the task, which will be faster, which is more appropriate. And also, this is a very intensive task. So we're doing literally millions of positions per second, and in most situations on programming you don't need to do this, so this is for like ultra performance when you need it. What this also is just showing my experience of using languages I'm not very familiar with and trying to get them to work. How easy is it to get them to run? What's the performance like? Is it annoying? How long did it take me? Things like this. So just to explain the algorithm, this is just basically a bitboard chess engine like most things. And the reason we use bitboards, this is because it's faster, because we have basically lookup tables for every piece that are pre-computed, and we don't need to loop through anything. You basically use a while loop and then you remove the bit each time, but it's a lot faster because there's no looping. And that's the main reason it's faster. And the algorithm is basically just recursive. So what we're testing here is just from the starting chess position, find all the starting moves. For every starting move, play the opponent's moves, and for all of those moves, play your response until we get to 6. And that's what we get, and the result we're looking for is 119,060,324. You can watch the previous video if you want the full detail of how bitboards work. Just to show you, some of this code is actually pretty bad, meaning that it's not really the way I'd normally code. So it's all in one function. Literally all in one function, no extraction at all, except for some minor cases. And I'm doing stuff like this, and it's all in one function, all just using regions, and very long, and I would probably code a lot better. This is not how I would normally code it, it's for performance. Here's an example of how I would normally code. So what I would do is something like this. So int move count equals get moves, extract the function, make move, and an unmake move. The reason I didn't do this is just because it can create bugs when you try and change the algorithm in some way. I actually trying to make move better by extracting functions to move piece, remove piece, move piece, promote, and then I created bugs. So I test this, and it gives me a bug. Now if I test them both against each other, so run perf 2, inline versus functions, I created a bug. They're not the same result. So there's a reason I didn't change the algorithm because it's very bug prone. If you just make a slight typo or have a slight flaw in logic, you'll get inconsistent results. So to stop myself from debugging this for hours, I basically kept it like spaghetti code in all examples. And the reason why you want to keep it in the same function normally is because when you call functions, it does have a cost, and sometimes the compiler will inline it, sometimes it won't. So it's just safer to put it inline yourself and then take away the doubt. So here's the C++ code, which is what the base language was. There isn't much difference here. I basically just... so I have general constants at the top, because I didn't want to copy and paste them into a header file, and I put the, if I go here, constant CPP, I have these in there, and then a header file linking those in, just because they're so big, basically. Other than that, it's basically the same code. I just neatened it up and got rid of all the other stuff because the other stuff was just for testing. But other than that, it's basically the same. and onto the other languages. Alright, so onto C. C was basically a clone of C++. There's no difference at all. The only difference I had was I didn't use bools because I couldn't be able to, link the header file in. So I just used ints instead and just made a global variable, constant true, like that, and then just use ints. That's literally the only change I made from the C. If I show you C and C++ next to each other, you can't tell the difference. Honestly, it's the same code. Basically, the way I code in C++ is basically C with bool types, stdc out, and vectors. That's basically how I code in C++. I ignore 90% of its features. So it basically is C code, really. There's not much difference at all. But I don't know why, but the C code was slower. It's maybe something to do... I chose optimization level 3, but it seems slower. So I don't really know. Maybe someone else could optimize the C code better than me. I don't know. Right, now we have C#. C# I actually improved quite a lot just by copying the C code. So I copied the C code. Before I was using... that was just the example before. So before I was using a struct and just sending the struct and copying it each time, I decided to just copy directly from the C++ code and then change it, fix the errors. One annoying thing about C# is the way they use multi-dimensional arrays. Of course, I'm using span in C# because span doesn't allocate on the heap. So that will actually create, it will be on the heap because it's not known at compile time. Because you can actually use you could actually do this in C#, depth, which is not a compile time known value. So it basically will allocate on the heap when you create an array. So as I know the value, it doesn't go over 50. I know that by testing. It will in other tests. So if you go to a position with more than 50 moves, it will actually give you an error. Anyway, for this test, it's fine. So we do this just to specify we're on the stack. We don't want it to be heap allocated. It's faster. Other annoying thing about C#, one annoying thing about C# is how they do multi-dimensional arrays. You see here in between bitboards, we have to put a comma in between. So they use commas and not that, whereas in C it would look like this, like that. It's the only C# is the only language I've seen do this. Honestly, I don't know why. It does make it a bit annoying, especially when I have to it's not that annoying, but I have to make this comma and change it wherever I have a multi-dimensional array. It's not that annoying, but also changing the constant names is a bit annoying because here this would be const unsigned long, and then you got to change it to public static read only u long. Bit tedious, but anyway, I got it working. And it was faster, so that's the C# code. Alright, now we have D. I'm not sure if many people have actually heard of this language. It was supposed to replace C++, but it didn't really catch on. I had a kind of problem linking it and getting it to work on the path, so I couldn't actually call it. So I decided to just put the file in the place where it was installed and then just run it using... You run the main, was it dmd.exe, and then put in main.d, and it worked. And then use optimization as well if you need to optimize, and it creates the exe for you. That's all I did, and it worked. Alright, so yeah, it doesn't work in Visual Studio Code. There's no syntax highlighting, so I'll just do it here. This is D. It basically looks exactly the same as C. Honestly, there's not much difference. A few differences in how you declare variables. So they also use, when you declare an array, you have to use square brackets, which is just annoying. You just have to copy it. It's not too bad. You basically just Control F and then look for the curly brace and then replace them with the square ones. They also do a different order, and they have a ulong type, which it's not too bad. It's just a bit annoying to convert it over. They also, with imports, you got different ways of importing, but I believe it uses C anyway. You got stdio. I don't really know too much about this language at all, but it wasn't too bad to get working. The most annoying thing was just it wouldn't install properly, and it was pretty slow. Honestly, it's supposed to be like a C++ clone, but it was very slow. I don't know what I did wrong, or if I did anything wrong, or if it's just the language. It was very slow, honestly. Right, so next we have Go. Go I didn't change at all, really. I couldn't get it faster. I tried copying the C code directly, and then it still wasn't faster, so I just kept it the same. Go is very easy to get working. Took almost no time at all. Basically just changing everything, getting rid of the parentheses, But Go is very easy. There's not much I can really say about Go, honestly. It is weird not to use the colons in between the type, but that's just how it works. Also, but yeah, I mean, it's a fairly easy language. It's also very fast considering it's garbage collected, and the module system is also very easy. So in Go, for example, if you want to just link files, you can just keep them all in the same package and just say package main, new file, package main, package main on top of everything, and it just links it all together for you, and you don't have to do anything. Of course, you want to create a package, you can if you want, but easier just to put package main above everything and just have different files that way. The one disadvantage of that is basically you have to know where things are, because if you don't know where things are and it doesn't tell you, like, it will tell you a lot of the time if it's linked, but if you don't have it open, it won't always tell you where everything is. So it can be hard to find stuff. But anyway, Go is very easy to learn. The next we have Java. So the problem with Java is it doesn't support ulong or uint64s. It only supports longs, which are signed, and you can kind of convert them into usigned using a function call. The problem is a lot of these values go beyond the max value, so you can't even say long equals this. But look at, so I basically had to convert them to big integers, and this is what this looks like. This is what this looks like. Just end pages and pages and pages. Big integer, big integer, big integer, big integer, big integer. Very, very tedious. And I couldn't get it to work. I just basically had to change the algorithm because I couldn't, put all this in the 64 by 4096 array. I couldn't do all this for all that, so I basically had to change the algorithm a bit, and I created loads of bugs, and I couldn't fix the bugs, and not worth the effort, honestly. Plus you have to go into OOP madness. So instead of using the standard way of using or and, like say you do, I don't know, bitboard and bitboard like this, you don't do this. You got to go dot and. See, look, I mean, what the hell even is this? You got to say board bitboard array anded with move constants whiteboard target at dot signum, which basically checks if it's 0 or not. I don't even know. And then if you want to remove one, you got to say anded with subtracted by big integer 1. It's like everything's an object in this. I'm pretty sure if I did get this working, it would be extremely slow because big integers are classes, and I'm creating hundreds of classes per cycle, which would be a lot of garbage collection, so it wouldn't be very fast at all. So Java's not a bad language. Well, some people would disagree with me. I don't think Java's bad, but it's just very bad for this task because it doesn't support, it's kind of too high level. It doesn't support longs or this, it doesn't support this algorithm at all. For other algorithms, you probably have a lot easier time using Java. Not this though. This is just very specific and not suited for the task at all. So next we have nim. So the thing that drove me absolutely crazy in nim, and the reason why I didn't want to use it before, is because you have to, if you look here, U64, you have to put that on every U64 value. And look how many constants I have. I mean, it's not that bad. I basically have to look for the comma and then replace it with U64 comma and then fix it at the end because you can't have U64. But still, look, what? Literally on every value. On every value, U64, 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 U64. I'm sure nim would be fine when you don't have to, build this project. It would be a lot easier. Still very tedious though, considering how many constants I have. Anyway, so I got it working. Other than that, there weren't too many problems with nim. The main problems you have, again, to follow tradition, we are going to use curly braces because I copied this from Python. I didn't change it. But what nim uses is actually spaces. So if you look here, they're actually spaces. They're not tabs. They're not spaces at all. Or they're not tabs at all. The problem with that is that VS Code likes to put in tabs for you when you don't want them. So I get a lot of situations where I just like delete something or make a new line and then it would put in tabs for you and have to delete the tabs, otherwise get an error. I'm guessing that you can change that in VS Code somewhere. I just couldn't be bothered because it's a useful feature in 90% of the languages I use in VS Code. So I basically just had to grit my teeth and just add spaces in manually when I needed to. Other than that, it's pretty much standard and doesn't really change much nim. The and is a bit weird. That's the and, but I guess it's clearer what you're using. But yeah, it wasn't too bad, and Nim was relatively fast anyway. But I definitely prefer Nim over Python, honestly. But they're both kind of annoying in my opinion. I prefer using curly braces. Alright, now Odin. For this Odin, I basically copy the C code again, trying to make it as fast as possible, and I couldn't get it much faster, honestly. I'm not sure if there's another way to optimize it, or I tried to remove, because there's inbuilt bounds checking in Odin. I tried to remove that with compiler flags, but it still wasn't, it was still about the same speed. So I don't know, maybe I did something wrong, I don't know. But Odin is very easy to learn, honestly. It's very simple. One really weird thing is that when you use a constant array, you have to basically make it mutable and then say and read-only data, because if you want to access a constant array, you need to use a constant index, and of course you don't always have a constant index that's compile time known. It doesn't have anything like comp time either, like in Zig. If you have to basically make it mutable and then say read-only data to make it not mutable, but you can access it with a non-compile time no value. Because say if I want to look for the black king position and then put it in square bitboards or use it as an index, you can't do that in Odin unless you make it mutable. The only other thing in Odin is you can't use plus, so you got to use plus equals 1 everywhere. So just replace every plus you find with plus equals 1, and then it basically just works. But I couldn't get it any faster than it was. I'm not sure why. So we have Python. Python is basically exactly the same before. I mean, some people say you should use like some C. I think it's called Codon or something like this. I couldn't. There was no person that could get it to work on Windows. So maybe someone could compile this in Codon. Also looked at there's things called like PyPy, which will basically make this a JIT compiled language, but it doesn't work with NumPy. It couldn't find NumPy. So I don't really know. I just left it the same. And again, the only thing that's really annoying about Python is I made them, I'm not sure if you need to do this, but I basically made all the constants use NumPy arrays to make them specify their U64. So after every array, I have this at the end. I have this at the end, a D type equals num, yeah, like that. After every value. I don't know if it's necessary to do this, but I thought, better to specify. That's the only really annoying thing about Python. And then again, like same before, I haven't changed the code at all. Curly braces everywhere, with some semicolons sometimes. Curly braces are just easier than indentation. But anyway, yeah, Python code is exactly the same as before. Right, next we have Rust. So Rust was obviously tainted by my problem with the Stack Overflow. If that weren't the case, and I didn't get a Stack Overflow problem, Rust wouldn't have been that hard at all. I basically simplified it this time just by making it usize. Make everything usize, and then you have no problems at all. There's no casting anymore. I think I have to cast it here, I believe, because it's. But other than that, I don't. Basically, I turn everything into usize. I also tested a struct with. I tested a struct in Python as well. It was slower, which is great. I tested a struct in why is everything open. So I tested a struct as well, but it was about the same. Didn't change the performance at all. With the struct though, you don't need to use unsafe, so it kind of, it's preferred more with Rust. But it was about the same speed, so I didn't see a difference. But I basically made so here. King position is a usize, you're a usize, so there's no more casts anymore. Before I was saying as usize. And so you just make it a usize and you don't need to cast anymore, and it's just a lot better. Other than that, it's about the same, and I couldn't really get Rust to go any faster. So obviously someone who's better than me at Rust probably could do this, but yeah, I'm not an expert, so I'll leave it to someone else. So next we have Swift. I don't know which was worse, Swift or Java, because oh my god, Swift is just so bad on Windows. I don't know if this is just quirks on Windows, but the performance was terrible. The compile time took on average about 2 to 3 minutes, sometimes 6 minutes to compile. And another really annoying thing, well I don't know why, but in Swift basically you make everything a capital, so every type is a capital, which it's not that annoying, but yeah, it's weird. Also everything's in square brackets, which is similar to Rust. So when you make an array, you make everything square brackets. The thing that really annoyed me a lot in Swift is Swift doesn't like integer overflows. it just forgets to tell you that it doesn't like integer overflows, and it would just crash. It would just crash and not tell you anything. Not even give you a warning message, nothing. Just crash, nothing. So I had to find out where it was using print messages, trying to find where it crashed, and having to compile for 3 minutes each time. So I was working on other projects while waiting for it to compile. Like, oh, it's compiled. Okay. Oh, it wasn't there. Okay, and make another print message. Compile. Okay, work on another project. It's like 3 minutes each time. Basically, I found it was here that was the problem, and the way to fix it was just to put an and there, which basically just ignores the overflow, I believe. And that fixed the problem. But again, if you have strict, like no overflows, it will crash, undefined behavior. Tell me where it is. I don't know if this is a Windows problem or if this is the same with all Swift. Terrible design, honestly. Then, say we have a function here, like get rug attacks, and we put in start square, occupancy, whatever. We have the parameters. In Swift, you need to specify them when you call the function, which would be great if it were optional. But it's not optional. Apparently I can't search for it, so I'll just Control F. I'll just delete it by accident, Control F, and just look. So here, you have get rug attacks, starting square, occupancy. And the next one, starting square, occupancy. What if you don't remember it? You gotta like, the compiler gives you an error every time. You gotta specify. This would be great if it were optional. If it was optional, you could basically select the order of the parameters. It'd be a good feature. If it's mandatory, it's just annoying, and you don't remember. Like, and say if you have a really long function with loads of, you have to literally put the names of every parameter in every time, which is terrible. And then I don't know why, but the performance was garbage, absolute garbage. Like if I got Java to work, Java would have been faster than this. I don't know, this is probably just a quirk with Windows. Someone on Mac could probably get this to work, but Swift on Windows, not usable. So finally we have Zig. So I made the Zig version a long time ago and decided to update it. I updated it just by copying the C code and just fixing the errors, just to make sure it was as efficient as possible. The code bases aren't on the same place because I just copied it from C and I couldn't be able to change it. It's too much code. So one really annoying thing about Zig that I completely forgot is when you have a multi-dimensional array like this. You look how big this array is, 512 by 64, and every time I have to spam this. I have to spam, oh, this is a U64, it's 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 a U64. Every time, honestly, I tell you up here it's a U64. Why do I have to specify it's a U64 here as well? Just unnecessary. But why? Why do I need to do this? That does drive you crazy in Zig, but everything else was pretty much fine. Alright, so I decided to change most things to U sizes. So this starting square is a U size, target square is a U size, this returns a U size, De Bruyne also went to a U size, and it just fixes it just basically makes it a lot easier to work with. This ignores the integer overflow in Zig. It's the way to do it. You don't really, it's not exactly safer to be honest, it just means you're ignoring the integer overflow. It's just for performance anyway. I believe in release mode it ignores the integer overflows anyway. But in debug mode you have to do that to get to run. Other than that, basically, yeah, Zig code is exactly the same. And I got it ridiculously quick. So Zig code is actually exactly the same as C code, C performance in this. I don't really know why that's different. I was using a struct before, maybe that's why. And I used it a long time ago. Maybe all the casting was bad, I don't know. But making everything U size and then copying the C code directly and changing it made it a lot faster. Alright, so here are the results. So I have no idea why, but C++ was faster than C. I'm guessing it's something to do with optimization. I tried to use the same optimization for C. I just used GCC 03 and it seemed to be slower, I don't know. Zig was exactly the same speed as C. It's basically margin of error, this. But I don't know why C++ is faster. C# they got a big improvement this time, basically just by copying the C code. D was very slow. I mean, D is supposed to be a replacement for C in C++, but it's pretty slow here. Don't know if I did that wrong. Don't know. Go was basically the same. Java, I couldn't get it to work. Too much effort, honestly. Nim, surprisingly fast. It's obviously not the same as C code. maybe half the speed, but that is pretty impressive considering it's basically, I mean, it's not really an interpreted language, but it's similar to Python in some ways. Odin I couldn't really get much faster. That's probably as fast as I could get it. I'm not sure why C and Odin have a difference, because in theory they should be similar. Python, yeah, obviously, if I could get it to work using another interpreter or compiler, maybe, yeah, obviously it would be a lot faster, but 23 minutes is pretty terrible. Rust, again, I couldn't improve the speed much, so I don't know, someone else will have to try that. And Swift, what the hell is Swift? Honestly, 37 seconds? Terrible. I'm pretty sure this is just a Windows problem. I don't know. Obviously someone on iOS will have to test this. But yeah, Swift is not very good on Windows. But those are the numbers. If you want to check the code is in the GitHub in the description. I'm sure that probably a lot of you will get better results than I did. But anyway, thanks for watching. See you guys next time.